Alright, so let's look at this problem now. Permutation in string. So the problem is basically we have to figure out if S1 is a permutation of one of the substring of S2. You all know what a permutation is. It's basically same number of characters and it's exactly the same string but it can be rearranged. So how do we start solving this? Okay, so let's think of a more sliding window approach. In sliding window, what we can do, we know that the length of, let's look at example 1, the length of S1 is 2. So what we can have is, we can first check these two characters, the first two characters, and see if they have the same exact frequency count and also the character count of every character in S1. If it matches, then we return true. If it doesn't, then we move on and check to the next two strings and so on until we reach the end of the string. If none of our substrings are matching, then we return false. Okay, so the idea is straightforward. I won't bore you with the details. Let's directly try to code it up. But the approach which I am thinking here is, since I am making use of a window size of a certain fixed value and then I am moving both my right pointer and my left pointer. So which type of algorithm comes to your mind? Yes, it's the sliding window one. Alright. You can look at the constraints. It is also given that S1 and S2 will only consist of lowercase English letters. So we know that there are 26 of those. Okay, so let's start with our coding. So I need to store the count of each character. So for that I would need either a map or a frequency vector. So let me use a frequency vector. And it will be of size 26. And I need two of those. One for the S1 strings and another one for S2. One thing is clear, that at every fixed window size, I will basically compare the vectors. If my vectors are equal, I will return true or else false otherwise. Okay. And it's not given here that S2 is greater than S1 always. So we need to have a check. So if our S1 dot size is greater than S2 size, it means that S1's permutation cannot be in our S2, so we directly return false in this case. Another thing is, we need to first keep a count of frequency 1, which will be the count of S1. So for that, I'll basically simply just write frequency 1 of my C and minus A because it's just 26 size. Okay, this is done. Now we need to look in our S2 strings of a fixed size, which will be from S1 0 to S1 dot size first. So let me have my right pointer. So right will be nothing but my S1 dot size over here, and my left will be nothing but my will be my starting point. So I need to first go through the loop of it. This is the first step. I mean, you can code it in different ways. Some people might find my way of coding a little complicated. However, it's up to you. The main thing is the idea. So I'm basically running the loop from 0 to R being my S1 dot size. So basically I've taken my initial window size and I will I will fill my frequency 2. So my frequency 2 is S2 of I, and here it's minus A and then plus plus. Once this is done, I will do an initial check. If my frequency 1 is equal to my frequency 2, then I return true directly. Okay, let's say that the first length did not match. So as I said, that at every step I will continue moving my left and right pointer. since I am dealing with fixed sliding window problem here. So let's first add our rth character, which will be s2 of r minus a, and here plus plus, and we also need to decrease our left pointer, so that would be s2 of l minus a, here minus minus. Then we have to move both of these, and you can have a check anywhere. So I'll just keep a check here. If my frequency 1 is equal to frequency 2, then I basically return true. If nothing matches, we complete the loop, our while loop, and nothing matches, so we return false in the end. Let's run and check if this runs fine or not. Okay, perfect, it runs fine. We can submit it, but first let's discuss its space and time complexity. So the time complexity of this solution, what am I doing? I'm basically going through this entire s2 string once and for all. So my r pointer is at max going from s1 size till the end of string, and my left pointer is going, so roughly we can say both pointers are going till n size, till n length of the s2. So my time complexity will be nothing but n, where n is my s2 dot size. What is the space complexity? Since I am using two frequency arrays of constant size, you can, it's constant, so it's exactly big of 26 and big of plus 26, but you can, since it's constant, it's just a constant space. Okay, can we do better than this? Well, you can do small optimizations here and there, but the time complexity won't improve much better than O of n. That's the best in this case. However, you can improve on the space complexity. Since I'm using two frequency arrays, one for S1 and one for S2, you can simply use one, and then you can also keep track of, you can make a variable of keeping track of all the characters, and one by one, if you can match, if in frequency 1 all the 26 indexes are 0, and also the count of characters is matching, then you can say that it's true. But anyways, I'm not going to code it up, since I think it's a little difficult to understand from what here it is, and it doesn't improve much on the complexity. So here it is. Let's submit it. Perfect.